Alright, so I want to do a quick review. Exponential models, we introduced this new unit. And so here is our big equation, y equals ab to the x power. The key to exponentials, they have that variable x up in the exponent, right? So a couple key things. So a is our initial quantity, some starting amount, whatever the situation is. B, we call that the exponential base. That word base is important. That's going to help us when we start dealing with logs later on in this chapter, in this unit. And so, couple keys, if B is greater than 1, so if this base is greater than 1, hey, we've got growth. Our amount's getting bigger, bigger, bigger. If it's in between 0 and 1, then we've got exponential decay. That amount is decreasing, decreasing, decreasing. Okay? X is our independent variable, like it always is. A lot of times it's time when we are actually doing an application like money growing or population growing or something with respect to time. And Y, in this case, is a final quantity. Okay? So what if we're given a couple of points and we want to come up with that equation? So here's a couple values. We know that we've got exponential function and it goes through these 2 points. So I put some steps over here. Let's just plug both points in for x and y into this equation. So let's see what that would give us. So for my first one I would have 2 equals ab to the second power. For this one I would get 4 equals ab to the third power. Now notice there's 2 variables, a and b. I don't know what either one of them is. Okay, that's why I have to have 2 equations here to help me. Let's rearrange each and get a by itself. So in this one, if I divided b over, I would get a equals 2 over b squared. And this one, of course, a would equal 4 over b cubed. Okay? Now, because these are both a equals, we can set them equal and solve for b. So 2 over b squared equals 4 over b cubed. Or basically we're saying a equals a. Now let's rearrange this. This is where algebra skills come in. And so let's cross multiply maybe. Okay? In fact, let's just do this. Let's multiply b cubed up here and divide our 2 over. I think you'll be able to see what I do here. B cubed over b squared equals 4 over 2. Okay, I just rearranged. So I brought this up and I brought my 2 down. The reason I'm doing that is because I'm solving for b. So now let's clean this up. Well, what's b cubed divided by b squared? Well, that's just b. And what's 4 divided by 2? Well, it's 2. So I know what b is now. It's 2. So now we can go back to either one of these equations. Since I know b, we can plug it in and we're going to solve. We're going to figure out what a is. So 2, let's go to this first equation. 2 equals a times 2 squared. And now let's just rearrange that. Let's get a all by itself. So a equals 2 over 2 squared. Of course, that's 2 over 4, which is 1/2. So now we know what a is. Let's just write our final equation. So y equals 1/2 times 2 to the x, and we have our model. Okay, let's go ahead and look at graphing. What if we needed to graph something? Well, identify the correct graph. Now, here's the easiest thing I think to look for. What if we just plugged a 0 in for x? Well, 2 to the 0 would be 1, so 4 times 1. Now, 2 is bigger than 1, so this is clearly growth. So you could cross out this one. These are all growth. But where is it going to go through at x equals 0? Well, it's going to go through 4. That one doesn't work. That one doesn't, or this one actually does work. This one doesn't work. Goes through 2. And so, not too bad to identify. Worst case though, gosh, go to Desmos.com, plug it in, graph it, and find the graph that matches. Okay? Now, quick review as well, identifying growth versus decay. Remember, it's all about this b value. Bigger than 1, it's growth. In between 0 and 1, it's decay. So what's this? Can you see it? Decay, growth, decay, decay, growth. That's all you have to look at, okay? Now, how about we get a word problem? They throw some application problems at us. Well, here's some basic steps I like to think maybe to solve it. We're going to use this equation. So we want to plug things into that. Where are things going to go? If growth is occurring, then B is 1 plus whatever the rate of increase they tell us. If it's decay, then you do 1 minus the rate. Plug things in and solve them. Okay, let's look at a couple quick examples. So modeling growth. Cell phone usage grew, right? 22%. Okay, write a function to model it. Well, started at 34 million, so y equals 34, and you could type in million, or I'll just do this function as in terms of millions. What is my rate of growth? Well, it's going up 22% a year, so 1 plus 0.22 to the x. And of course that's just 1.22 if you put them together. Now we could plug in different times and get a value if they asked us anything. How about this one? We've got decay. Population is decreasing. Notice the key words that tell us what's going on. 30% each year. The population's 2356. So that's a starting amount. 2356. Well, 1 minus 0.3 to the x, and of course 1 minus 0.3, that would be 0.7. Hey, there's our function, there's our model. We can go calculate whatever we need. Okay, so this ought to help you through the quiz. These are some big ideas want to feel comfortable with.